All right, let's go through problem number 4 on your in-class problems. So while we're looking at that or working through on a separate sheet of paper, let's kind of do this. We'll try to do some pauses along the way and kind of keep you moving. So in-class problem number 4, a car starts from rest and travels at 5 seconds with a constant velocity, a constant acceleration of negative 1.5 meters per second squared. What is the final velocity of the car? Go ahead and hit pause. Circle the key numbers, make your list of variables, then unpause it to make sure you have it right. All right, so hopefully you went through and have some of the things highlighted and circled that I have. The car starts from rest. That's an implied number. That gives us the initial velocity of 0. Travels for 5 seconds. That tells me time. Accelerates at negative 1.5 meters per second squared. Negative, don't forget the negative. The negative tells you the direction that the object is moving in the negative direction. So remember, oops, I was actually dragging that the wrong way. So to the right is positive, to the left is negative. So it's accelerating to the left. Doesn't mean it's moving to the left, it's accelerating to the left. So now go through and based upon that, now we don't forget about this second question, just pretend like that isn't there yet. Go through and say, hey, I don't know this delta x, figure out which equation you have that doesn't have a delta x in it. Go ahead and hit pause. So hopefully when you go through, you looked at your list of equations and say, hey, equation number 2 does not have a delta x in it. So we're going to use equation number 2. We're going to use equation number 2 and say equation number 2 is your final velocity is equal to initial velocity plus VF is equal to VI plus A times T. Go ahead and hit pause and then solve that equation. All right, so your numbers should be VF is equal to 0 plus negative 1.5 times 5. Then your final velocity is going to be negative 7.5 meters per second. That negative tells me the direction is to, that's maybe hard to see, but that tells me the direction, and it's telling me that it's moving in the negative direction, which is going to be to the left. Now you don't actually have to put left, the negative gives us that direction. Okay? Last part of this problem is to go through and to determine what is, how far does it go. So now what we are doing is we are solving, oops, sorry, wrong button. We're now solving for final velocity. The best practice, the best approach would now be to pretend like I don't know that final velocity, if at all possible. So if we have an equation that doesn't have a final velocity in it, yes, let's use that one for the second part. So if we look and say, I need one that doesn't have final velocity, there is this equation number 3 that doesn't have final velocity in it. Go ahead and hit pause and solve that problem. All right. So when you go through and you plug in all your numbers, remember your initial velocity is 0, so 0 times t is 0. Then you can go through and plug in all these other numbers. I want to draw your attention to that value right there. It's a negative displacement. What that means is we started here at 0 meters. Remember, positive, negative. They started here at 0 meters and then they went 18.75 meters that way to the left. That's what that negative sign means. It moved to the left. Hopefully those 2 extra problems are going to help you work through the worksheet called constant acceleration problems. If you have any questions, let me know. Have a good weekend, everyone.